Hello, I'm Jam Victorio. Welcome to this tutorial on how to use Texture Pabrika. Texture Pabrika is a Blender add-on created to make highly detailed PBR texture maps easier to create from within Blender. In this tutorial, you'll learn all the basics of how to use Texture Pabrika's three main utilities to get you started on your texturing projects. For this, we'll use this lantern model that comes with the Texture Pabrika add-on, from which we'll extract all data onto a less dense model using the Map Baker utility. Use that data to create detailed texture maps using Blender's shader nodes together with Texture Pabrika's Node Builder utility, and finally export our finished textures using the Exporter utility so that we can use them on other render engines. Alright, now before we get started, there's a few things that we need to set up. First things first, let's install Texture Pabrika. To do that, let's go to Edit, Preferences, and click Add-ons, and click the Install button. Now navigate to the location of texturepabrika.py and hit Install Add. Now remember to enable by checking the box, and we can check if Texture Pabrika is running by clicking on our 3D viewport and pressing N on our keyboard. There should be a Texture Pabrika tab over here. Alright, now we are going to enable Node Wrangler. Texture Pabrika works without Node Wrangler, but it's a really useful add-on, especially since we're working with nodes, and we can save ourselves a lot of trouble by making use of this great add-on that comes pre-packed with Blender. After that, we are going to enable automatic packing. To do that, go to File, External Data, Automatically Pack Resources. We are going to be working with several image textures, so we want Blender to pack any changes we make to our textures and not have to worry about saving each time we make a small change. Now we're also going to set our render engine to Eevee. Now to do that, let's go to Render Settings and set our render engine to Eevee. Alright, now finally, we are going to save our project. The location of any output file generated by Texture Pabrika is going to be relative to the location of your blend file, so it's a good practice to save your project even if you haven't started working on anything yet. Now that we're done preparing Blender, let's get our objects ready for our Map Baker utility. Alright, now in this lesson, we are going to talk about Texture Pabrika's Map Baker utility. Now there are two ways for you to use the Map Baker utility. Bake from one collection to another collection, or bake data onto a mesh's own vertex color attributes, which is useful if you want to use some cycles render features on Eevee or use information like lighting or ambient occlusion on geometry nodes. Now for this project, we are going to be baking from one collection to another collection. Now we are going to have to fill in all of this information over here, so let me go over each one. For our source collection, which is going to be our high poly collection, we need to make sure that materials are properly assigned. So if we head over to our material preview over here, you'll see that I've changed the base color for each material just so you can see which material goes where, but there really isn't any need for you to tweak anything. We also need to make sure that a unique suffix is added to the names of all of our high polys. And we also need to make sure that each of our high poly has a matching low poly. So if we open up our low poly collection over here, you'll see that we have matching names and matching geometries for each one. All right, now our low poly collection will be our target collection. And for our target collection, we are also going to need a unique suffix added to the names of all of our low polys. We also need to make sure that we have our UV maps laid out. Lastly, we are going to need a target material. This target material needs to be assigned on the topmost material slot of each of our low polys. We also need to take note of our output file destination. This is where our output files are going to be saved. Now in the next lesson, we are going to talk about the kinds of data that we can extract using the Map Baker utility. All right, now in this lesson, we are going to talk about all the kinds of data that we can extract using the map baker utility. And we'll see all of them down here. All right, now let me go over each one. Surface info refers to data that can be extracted using only the surface of an object. So things like ambient occlusion, bevel information, surface depth are all baked onto the RGB channels of the surface info map. Lighting info refers to data that is generated using all the light sources in a scene. Indexers refers to data that identifies surface, whether by material or by island, and we can set this either automatically or through vertex color attribute. Normals provide data on how light should interact with the surface. World normals refers to the direction of a surface in relation to the world. And world position refers to the position of an object in relation to the world. Now, in the next lesson, we are going to talk about things that you need to know during the bake process. Now, in this lesson, we are going to start our bake, but before we do that, let me save our project one more time. And then let's put in all the information the texture Pabrika needs. So this is going to be lantern high, lantern low, and then this is going to be lantern matte. Let's also bring down this value over here since we don't need too much of that. And let's also bring down this value over here just so we can bake out our maps faster. Now I think we're ready and let's start our bake. Now, just to inform you, because Blender UI freezes when it's running a script, there is no way for us to check on the progress of our bake from within Blender. So what we are going to do is to navigate to our output file destination using our operating system's file browser, where we'll see exactly how our bake is turning out. Now, I think it's worth knowing that Texture Paprika generates a lot of stuff like view layers and shader nodes during the bake process. So if for some reason it gets interrupted, you might end up with some data on your file that you might not recognize. In that case, you might want to try and clean up all of these files, but the best thing to do would be to take note of what caused the issue. Reopen a previously saved file, that way you're sure you're working with a clean working file, and then fix whatever it was that caused the issue. All right, after our bake is done, let me just head over to our shading workspace so that you can see that we have our data maps automatically added into our target material. All right, now in our next lesson, we are going to talk about Texture Paprika's node builder utility. We are going to set a few things up so that we can start building our textures for our lantern. Now, in this lesson, we are going to talk about Texture Paprika's node builder utility, which are the tools that you can find in this section over here. Now, the node builder utility simplifies the process of creating node groups with properties that can be stacked on top of each other. When you think about it, this is actually how a lot of surfaces in the real world arrive at a certain look, things accumulating one on top of the other. This is what we will try to replicate using the node builder utility. Now, all functionalities are made by nodes already existing within Blender. So if you have a workflow that you're comfortable in, or if you have an existing material library, you can use that in conjunction with Texture Paprika. The only thing that you need to know is that this exporter utility, which is the one down here, is designed to work with one specific node group, Texture Paprika's shader node group. Without this node group, the exporter utility might not be as useful. Now notice that the node builder is currently locked, and it has a warning. Clicking on Initialize tells Texture Paprika to build node groups using the properties that we have enabled. Generally, it would be a good idea to avoid having to reinitialize in the middle of a project, but in case you need to, it's not really going to be a big problem. You'll just have to reconnect a few things, which I'll show you later on. For now, since we haven't started, we don't have to worry about anything and we can go ahead and click initialize. Now we are given access to all the node builder functionalities. In the next lesson, we will create the basic texture Pabrika setup for our lantern material. In this lesson, we are going to create the basic texture Pabrika setup for our lantern material. And the first thing that we would need to do would be to delete this principal BSDF. We are going to replace that with a shader stack. Now what the shader stack is that it's a node group that allows us to stack shaders on top of each other, much like Blender's mixed shader node. But the great thing about being able to use Texture Pabrika to do this is that we can set a variable amount of inputs. So for example, we want a shader stack for 2, we can do that. A shader stack for 3, we can also do that. Shader stack for 5, we can also do that. But for our project, let's keep it simple and create a shader stack for 2. So let's click on shader stack and press G on our keyboard to move it around. And select both nodes and press F. All right. Now, each time we click on a button in this section, we are creating a unique node group. Now, what that means is that we can go inside any one of these node groups that we've created, change some values over here if we want, and not have to worry if we're affecting any other node on our network. Now, we are also going to need a shader, which we are going to call painted metal. So let's press F2 on our keyboard and type in the name that we want. Now let's connect the output of this painted metal to input 0 of our shader stack. All right. Now, as I've mentioned, this shader node group is what the exporter utility will need in order to export different textures. So let's say you have your own style of building your own node network. You can just think of this node as a principled BSDF. In fact, if we go inside, it's just a principled BSDF with a basic setup to allow Blender to interpret a normal map. Speaking of normal maps, let's connect our normal map. So let's head over to our data maps over here, and then let's connect the output of our normal map to our painted metal. So select painted metal, press F, and let's move this down here. Now to check if we have our setup working correctly, we can head over to our viewport over here and switch mode over to rendered. And let's also hide this lantern high since we're not going to use that anymore. And we can change this base color value just to see if that's working correctly. Now, in the next lesson, we are going to need to tell Blender which surfaces should our shader affect. And to do that, we are going to talk a little bit about data map nodes, and we are going to use the indexer map. Now, in this lesson, we are going to talk about Texture Pabrika's data map nodes. Data map nodes are node groups that interpret data created using the Texture Pabrika Map Baker utility. And we can create data map nodes using the buttons in this section. Now, each data map node has a corresponding data map that it can be used with. And for this instance, we are going to create an indexer node. And we are going to use this indexer node to tell our shader stack where to apply this painted metal shader to. So let's click on this indexer node, press G on our keyboard. All right. Now, to use this indexer node, we are going to have to connect it to our indexer map. So let's head over to our data maps over here. Select the indexer map and select the indexer node and press F on our keyboard. All right. Now, to preview the kind of data that we are getting, with Node Wrangler enabled, we can press Ctrl Shift on our keyboard and left click on this indexer node once. Now we can see we have two different shades of gray, which means that we have two different materials that we can choose from. And to isolate the area that we want, let's click on this isolated material color property and use the eyedropper on the region that we want. But the more accurate way to do it would be to head over to our render settings over here, and under color management, change display device to none. Now we can use the eyedropper on the region that we want. All right, now we can switch back display device back to sRGB. Now to check if we are getting the area that we want, let's press Ctrl Shift again on our keyboard and left click on this indexer node one more time. Now we can see that we are getting the area that we want, but we can fix this a little bit more by increasing the tolerance value. All right, now we are going to connect this isolated material output into our input 0 factor, which is going to tell our shader stack where to apply our painted metal to. And to check if we have our setup working right, let's press Ctrl Shift again and click on this shader stack. And that is going to connect our shader stack back to our material output. And it looks like we have our setup working just as we want it to. So in the next lesson, we are going to start detailing out our textures using the property array nodes. All right, now in this lesson, we are going to talk about Texture Pabrika's property array nodes. So what are property array nodes? Property array nodes are stackable node groups that control all the properties of a shader. So let me just quickly create a property array node so you can see what I'm talking about. And if we look closer on this property array node, you'll see that it has all the properties that this shader node group has. And these properties were determined when we initialized. Now, stackable means that we can basically create another property array node and connect properties one on top of the other. And since these are unique node groups, we can basically go inside one property array node, change some values over here, change some blending modes if we need to, and not have to worry if we're affecting any other property array node. This allows us to create a node structure that we can easily arrange and rearrange. So let me just quickly show you how that's done. On our keyboard, hold the control key and right click on our mouse and drag a line over all of these lines over here. And then we can just quickly swap places for this too, and press the F key as many times as there are properties to connect. Now, another great thing about being able to use a property array node is that a property array node group has all the properties that we can play around with to recreate the look of a particular component of our object's surface. I mean, when you think about it, there's always this layering of different components involved in the look of any surface. There's always a base material which accumulates impurities, is coated in some sort of finish, wears over time, and then gets all sorts of different buildups. A property array node has all the properties that we need in order to manage a particular aspect of our texture. Now let me just quickly talk about these inputs and outputs since it can be quite confusing. So all these inputs up here are designed to be connected to the output of another property array node. So we're not going to be touching any of these inputs. What we are going to be playing around with are the inputs down here, which will be changing values or be connecting to other nodes. Now, let me just quickly set up the components that we need for our painted metal shader. So this is going to be the metal component. And then this one is going to be our rust component. And then let's connect two more property array nodes, which we'll call the paint component. And then this one is going to be our rust component. Or sorry, not our rust component, but our dirt component. All right. Let's just quickly connect these components together. And then let's connect this dirt component, which is our topmost component, to our shader. All right. So there we go. Now in the next lesson, we are going to be detailing out each component. All right, now in this lesson, we are going to be detailing out our components, starting with our metal component. But before we do that, I just noticed that we don't have the proper viewport shading settings. So let's head over to our viewport shading settings over here and turn off scene lights and scene world. Now we can start working on our metal component. And the first thing that we would need to do would be to turn off all of this property array factors. This is going to let our metal node bypass all of these other nodes. Now on our metal node, we need to watch for which property we are working with, since as I've mentioned, these properties over here are meant to be connected to the output of another property array node. And doing anything here wouldn't really be doing anything to our lantern. Right? What we need to be working with are the properties down here. All right. So for our base color, let's set a gray value and let's set metalness to maximum. Also set specular to maximum. And then we can leave roughness at this value. All right. Now we have a very clean metal look. Now what we want, of course, is a little bit of realism. So we are going to work on this metal component a little bit more. And we are going to make use of this surface info node. Now, as I've mentioned, all data map nodes are designed to work with a corresponding data map. So let's select our surface info map and select our surface info node and press F on our keyboard. And then we are going to connect the output bevel into our roughness property. All right, now what we want is a little bit of variation on this different type of edges that we are seeing over here. So let's put in some values in this surface info node. Let's set bevel invert to 1, set bevel contrast to 7, and then set bevel shift to negative 0.2. All right, now we have a fairly convincing metal look, and we can jump right away to our rust component. But our rust component is going to be a little more difficult, so we are going to make use of this image stack. And we are going to talk about that in the next lesson. All right, now in this lesson, we are going to be working on our rust component. And the first thing that we would need to do would be to turn up this property array factor to 1. And this is going to let Blender evaluate all of our properties over here. Now, of course, for our rust component, what we want is a base color with a splotchy brownish orange texture. So what we are going to do is to make use of this image stack node. So what is an image stack node? An image stack node is a node group that will allow us to blend images or colors together. And since this is going to be a unique node group, we can basically go inside this node group, change some blending options if we need to, and not have to worry if we're going to be affecting any other node group. So let's create this image stack node, and we are going to position it down here. And then we are going to connect the output of this image stack node into our base color. Now, of course, what we want is to have variations of origin brown for our textures. So let's set this input 0 to a bright orange, this input 1 to a darker orange, and then this input 2 to a deep brown. All right, now to recreate the splotchy texture, we are going to make use of Blender's Musgrave texture node. So let's hit Shift A on our keyboard and then look for the Musgrave. Now what we want is to maintain control over all of these colors over here. So let's connect the output of this Musgrave texture into our input factor. Now let's set some values over here. So let's set 500 for scale, 15 for detail, and then 0.2 for dimension. Now, if we look closer at our texture, you'll see that we have a little bit of stretching over here. So what we are going to do to make use of Blender's texture coordinate nodes, let's hit Shift A again on our keyboard, and then let's look for the texture coordinate. Now we are going to connect the UV output of this texture coordinate node into our Musgrave textures vector input. All right. Now we are going to do the same thing for our input one factor, but we are going to change the scale value to 1000 just so we have a little bit of variation. Now, of course, we don't want rust all over our lantern, so we need to control where our rust occurs, and we are going to do that by making use of another image stack, which we are going to connect to our property array factor. And but this time we are only going to make use of an image stack for two inputs. All right, now let's connect the output of this image stack into our property array factor. And then we are going to make another surface info node. Of course, we need to connect this surface info node to our surface info map. So let's select that surface info map and then select the surface info node and then F. Right now we are going to connect this surface info, or we are going to connect the bevel output of our surface info node into this input. And then we are going to set some values over here. So let's set 10 for contrast and then bevel shift to negative 0.2. All right. Now, of course, we want rust to occur a little bit more random. So let's create another Musgrave texture node. And of course, to fix that stretching that occurs on our texture, we are going to need another texture coordinate node. So let's connect these nodes again. The output of the Musgrave texture into our input 0 factor. And then let's set some values over here. So let's set scale to 0.8, detail to 12, and then dimension to 0. All right. Now to finish off the look of our Rust component, we are going to need to change this bump value since of course Rust eats away at the surface. So we are going to set a value of 0.2498. All right. All right. Now I think we are done with our Rust component. The next thing that we need to work on would be our paint component, which is going to be similar to our Rust component and is in fact going to be a lot easier since we're not going to be needing any color variation. So I think we can take a break and let you explore and try out your own way of working with this paint component. And when we come back, we are going to be talking about how to use Blender's texture painting mode in conjunction with Texture Pabrika. All right, so welcome back. So I hope you were able to play around and explore different ways of how we can possibly work with our paint component. And at this point, I just like to show you my progress just so you get an idea of how you can possibly do it. And as I mentioned, we won't really need anything connected to our properties down here. And what I just did was to create a surface info node and a Musgrave texture, which I then combined using this image stack node. Now I pushed the values that I was getting by using this Blender brightness contrast node, which I then connected to this property array factor. And that gave me this paint flaking effect. All right. Now I also did turn down this bump factor to 0.08 so I could get some of our bump details from our other components to show through. And I also played around with some of our rust values just so I could get as much rust as I can to show. Now I also did go ahead and work on our dirt component, and I did that by creating a direction info node, which is another kind of data map, and combining it with a surface info node using another image stack. Now, in case you're wondering, this direction info node is designed to work with our world normals map. Now I also added a black areas component so I could darken these holes, but now I'm getting this darkening effect in areas where I don't want it to. So in this lesson, we are going to be talking about how we can use Blender's texture painting capability in conjunction with Texture Paprika. Now we would want to remove some of the blackening that's happening over here and some of the blackening that's happening over here as well. And here as well. All right. But before we jump to that, let me just point out that the features we are going to talk about are not features that are exclusive to Texture Paprika, but are features that are already included inside of Blender. Now, having said that, we are not going to talk about all the aspects of texture painting. Our goal here is just to give you an understanding of how to use texture painting comfortably in conjunction with Texture Paprika. All right? So the first thing that we would need to do would be to create an image texture node. All right, now we are going to connect, or we are going to combine this surface info node with this image texture, and we are going to do that using another image stack node. Let's create an image stack node for 2, and then let's move it down here. All right, now we are going to connect the AO output of our surface info node to our input 1 in our image stack. And we are going to connect the output image into our property array factor. Now we are going to connect the output color of our image texture into our input 0 factor. And then we are going to need a texture map. So let's click on new, and then let's give it a name. So let's call it black areas texture. I forgot to mention that during the first time we create a texture, we need to save it to an external location before Blender can pack it into our blend file. As you can see over here, we are in our UV editor, and we are going to save our image by heading over to Image, Save As, and now any change that we are going to do should now be automatically packed into our blend file. All right, now we can start texture painting. So let's head over to our texture painting mode, and then let's click on this tool tab, and then we are going to switch over mode to single image. Now we are going to select black areas texture. All right. Now to start texture painting, you need to set which mesh you want to be active. And to do that, hover your mouse over the mesh and then press Alt Q on your keyboard. All right. Now you need to remember that since we are connected to the input 0 factor, black means that we are going to be using the input on the bottom, and white means that we are going to be using the input on the top, which is going to be black. And that is what we want. All right. Let's press Control G again, or sorry, Alt Q again. So obviously you can use texture painting in a number of different ways. We just use it to control an input factor, but you can use it to control virtually any property that you want. All right, now in the next lesson, we are going to talk about another way that we can map an image into our object. All right, now in this lesson, we are going to learn about another way that we can map an image onto our object, And for that, we've created this property array node, which we placed on top of everything else. And we are going to name this property array node our manufacturer logo. All right. All right. Now for this property array node, we won't need any base color, any metallic information, any specular information, or any roughness information. What we are going to need is this bump value over here, which we are going to set to 0.24. Now we won't see anything happening as of yet since we are going to need an image that we will map onto our property array factor. Let's create image texture node, and then let's connect the output color into our property array factor. And then we are going to import our image or our manufacturer logo. So let's click on open, and then let's import this image. All right, so as of the moment, you will see this funky effect going on our object, and we are going to set which mesh we want our image to appear on. So to do that, we are going to select this image down here, or sorry, select this mesh down here, and we are going to head over to our object data properties and then create a new UV map, which we'll call logo UV. All right, now we are going to tell this image to use the logo UV, and to do that, we are going to create a new UV map node. Now we are going to set this to logo UV. All right, now as you can see, no other mesh on our object will have that image, since only this mesh has that logo UV and no other mesh. All right. Now, to position our image on our object, we are going to need to go to our UV editor, and then we are going to press tab on our keyboard so that we can go into edit mode. And right now we have turned off our overlays just so we can see it clearly. And then we are going to position our UVs. All right, now as of the moment, you will see that our image tiles all over our object. And to fix that, we are going to, sorry, let me just position this. We are going to change this from repeat to clip. All right. Move this around a bit. All right, there you go. Now, before we end this lesson, let's select this UV map again, since this is an important step, because Texture Pabrika exports your texture based on your currently active UV map. And if the wrong UV map is active on a mesh, you're going to have overlapping UVs and your exports won't look as you've intended them to. Now, we covered just about everything there is to know about Texture Pabrika's node builder. But before we can move on, in the next lesson, we are going to talk about reinitializing, which is something that you will have to do in order to work on this glass shader of our lantern. All right, now welcome back. So I've worked on our painted metal shader a little bit more, and I've reduced the amount of flaking that we're getting on these regions over here using Blender's texture painting capability. And now I think we're ready to start working on our glass shader. But the problem that we have right now is that if we, for example, create a new shader, we are going to connect to our shader stack over here. You'll see that given the properties that we have, we won't be able to make this transparent, which is something that we want for something like this. And the only way that we can fix this is through reinitializing. And to do that, we are going to open up our node builder settings. So let's click on this lock icon over here, and then let's enable alpha. Now, if we go over our warning, it says initializing clears all existing shader groups. That means is that once we reinitialize, Texture Pabrika is going to remove all Texture Pabrika shader node group. That means that any shader node group you currently have on your network will be removed and you'll have to reconnect a new shader node that has all these new properties. Now let me show you what's going to happen if I click on initialize. Now, as you can see, these two nodes over here no longer have data linked to them. In fact, this one says missing data block. But if we check on our property array node, you'll see that nothing has changed and this node over here still pretty much is working. But for this node over here, the only thing that we would want to do with something like this would be to replace it. Leave this node, create a new shader node. And if we look closer on our shader node, you'll see that it now has this alpha property. So let's connect our property array node back to our shader node. But since it now has this alpha property that we don't have on our property array node, pressing F on our keyboard won't work as efficiently. So we will have to reconnect this bump property manually. We are also going to connect our normal map node SF. Going to move. Now we are going to create another shader node dash shade. And then since we now have this alpha property, we can now make this transparent. But before we do that, we need to make sure that on our material settings over here, we have blend mode set to alpha hashed. All right. All right, so I'll let you work on your glass shader. And when we come back, we are finally going to be talking about the exporter utility, which is going to be our final step in the texture creation process. All right, so now we are done with creating the textures for our lantern. And if you look over to the right, you'll see that we have a fairly elaborate node network, which is going to be very difficult to transfer to another render engine. So in case that's something that we need to be doing, the best way to do that would be to export our textures. And for that, we are going to be using Texture Pabrika's exporter utility. Now, before we click on export over here, we need to make sure that we have the proper collection selected. This is given to you as an option since you might want to create collections for various ways of previewing your project. For example, you might have parts which you've duplicated to complete the look of your model as you were working on it. However, you want to set up a preview as long as you have a collection which does not have any duplicated parts or overlapping UVs, you're good to go on your export. So now let's put in the values that we want. So let's set 2048 for our output resolution. And then let's bring down margin to 2. It would also be good to take note of our output destination since, as I've mentioned, Blender UI freezes and the best way to check on the progress of our bake would be to navigate to our output folder using our operating system's file browser. So now I think we're ready to export our maps. So let's click on export and let's navigate to our output folder. Now exporting can take a little bit of time, so in case you're just checking on how your maps look, it would be good to turn off alpha and 32-bit and keep your output resolution low. You can turn this up once you're all set and ready to export your final output. Alright, so now we are done exporting our textures and these are ready to be used on any PBR-based render engine. Now that you know how to use Texture Pabrika, it's time for us to come clean. Like most other applications, Texture Pabrika does have a few flaws which I think is important for us to talk about so that you know how to get around it in case you encounter them in your projects. Number 1. Sometimes invalid collection error occurs even if collections are included, are visible, and are renderable in the active view layer. This is caused by the Blender memory cache, and the only solution we have for this is to save and restart Blender. Number 2. Sometimes mismatch warning occurs even if source and target objects are named properly. We suspect that this is caused by the name matching algorithm. For now, our suggested solution would be to change the name of the source and target objects, which we hope is doable in all cases. Number 3. Light info map bakes with the yellow color when indexer map and color information are turned on. We found that the bake material creation algorithm is what's causing this issue. For now, our solution would be to disable indexer when baking light info with color information. Number 4. Remove unused node groups is not removing all unused nodes. This again is caused by the Blender memory cache, and the only solution to fix that is to save and restart Blender. These are just some of the issues we found during testing and that we're hoping to fix with the next release of Texture Pabrika. If you've encountered any other issues you want to raise, or for any questions or clarifications, you can reach out through our website at texturepabrika.com. In the meantime, I hope you've learned a lot. Thanks for watching, and I'm excited to see what you'll come up with. Have a great day.